Hi, welcome to my video on the second derivative. And this video will talk about the shape of a curve, because the second derivative tells us about the shape of the curve. Let's recall. The first derivative is the slope of the tangent at a point on the curve of a function. And in this, I've done the derivative of polynomial functions so far. So y prime is the first derivative. And this is points on the polynomial with a degree greater than or equal to 2. So if your derivative is 0, then we have a maximum and or minimum points on the curve. If the derivative is greater than 0, then the slope of the curve is increasing. It's going up to the right. If the derivative is less than 0, then the slope of the curve is decreasing and it's going up to the left or it's going down to the right. But the second derivative, which is denoted by f double prime or y double prime or d squared y dx squared, the second derivative tells us about the shape of the curve. In other words, what we call the concavity of the term of the curve. The positive concavity is going upward. Concave, think of concave, concavity, concave, upward. Negative concavity, it's opening downward. So the second derivative tells us about the concavity, positive upward, negative downward. So if we have a parabola, which is like this, a parabola is concaved upward. This one is. Or we could have a parabola that's concave downward. We could also have what we call a cubic. Notice this is a cubic. A parabola has two x-intercepts. It could also have, a parabola can also have one x-intercept and be concave upward like that. Or it could have one x-intercept here, that's the vertex is right on the x-axis, and it's concave downward. But this is a cubic. And if you take this point right here, which is looks like it's probably what you say in the middle, on the left side, right here, it's concave downward, and on the right side is concave upward. So what we're going to find, we're going to look for this point, seek this point out by doing the double derivative, because the first derivative gives the slope of the tangent. The second derivative tells us about the concavity. What about we have a cubic graph that does this? In other words, it starts down here and it goes up and it cuts it at 3 points. But so this, the point that does the concavity would, let's say, be right here. So on the left side here, it's concave upwards. So the concavity is greater than 0. And on the left side, the concavity is going downward. So that means it's the concavity here, because it's, make sure, the concavity is opening upward, so the concavity here, because it's positive, is greater than 0. And because this is opening downward, similar to here, then this is concavity, which is less than 0. And we could have a quartex, and the quartex could be doing this. Notice we have 1, 2, 3, 4. I'm taking the simplest quartex, degree 4, and we have 4 x-intercepts. So here we could have 2 points. So if we take the middle of this one here, of this side, we take this point, and if we take this one right here, we could have another one here. So this point right here, notice on the left of this point, it's concaved upward. And on the right side, it's concave downward. Then when you take this one, on the left side is concave downward. And when you take the right side of this point here, it's concave upward. So this is a concavity point. That's second derivative is going to be greater than 0. And on this side of this point, the concavity is going to be negative, less than 0. When we look at this point, on the left side, the concavity is positive, so that's when f of x is greater than 0. And right here, for this point, on the right side, concavity is negative, that's when the double negative is less than 0. And the same holds true if we do a quartic and have 4 x-intercepts, 1, 2, 3, 4. And I just wanted to mention, notice if we just had just this alone, it would be a linear. When we bend it and come down and cut it again right here, twice, we have a parabola. Then when you bend again, it cuts the x-axis 3 times. This is a cubic. Then when it bends again and cuts it 4th time, then it's a quartic. And the point that this quartic has 2 points. Again, very similar to this one. So this point right here, on this side, on the right side, is concave downward. Second derivative is less than 0. On the left side, the concavity is positive. So this is when double derivative for this point is greater than 0. And when we take this point here, on the left side, it's opening downward. Double second derivative is going to be less than 0. And on the right side, the concavity for this point is opening up, so it's positive. So that's when the double derivative is greater than 0. And we get used to this. This is what I'm going to do more work on in the videos that follows this one. If a curve has a positive and a negative concavity, then it has an inflection, I-N-F-L-E-C-T-I-O-N, inflection point. So a parabola, this is a parabola that opens upward, but this parabola opens upward, but it doesn't open downward. It only opens one way up, so it has no inflection point. And this is a concavity, this is a parabola that opens downward, but it doesn't open up, so therefore it doesn't have an inflection point. So a parabola has no inflection point because the parabola opens up or down, but not both. This is a cubic cutting the x-axis 3 times. This cubic graph has an inflection point, and let's take it right again. Let's take it right here. On this side, it opens down. On this side, it opens up. So, because this point, this cubic this is the inflection point. Again, it opens down. This is a maximum point. This opens up, and this is the minimum point. So when you have an inflection point right here, now it opens down on one side, up on the other side, which means it'll have a maximum point and a minimum point on each side of the inflection point. And again, this happens here. This is a cubic cut to that 3 places, 1, 2, 3, and no doubles. In other words, there's no bouncing off. Like bouncing off means you have a parabola. So what happens is that the inflection point is right here. So on this side, it's concave downward, and on this side is concave upward. So notice that this is the maximum point, and this is the minimum point. So if this is the inflection point here, we have maximum on this side, minimum on this side. So on the maximum point, we have a negative concavity. The second derivative is less than 0. And when we have a minimum point, we have a positive concavity, and which means that the second derivative is greater than 0. Let's continue. An inflection point is a point where the curve changes concavity. So right here, the curve changes concavity from a negative over here to a positive. Or right here, it changes, this is a positive, it changes from a positive concavity to a negative concavity at this point. On one side of the inflection point, the curve opens up. That's where y prime, double prime, is greater than 0. On the other side of the inflection point, the curve opens down. That means that y prime is less than 0. So let's look at this cubic. Let's say that this point, negative 1, 1 is an inflection point of this function y. So f double prime is the second derivative. If f double prime equals 0, f double prime would equal 0 when x is equal to negative 1. So when we get a 0 for the second derivative, that's the value of x where the inflection point occurs. Now, if f double prime is greater than 0, double prime greater than 0, greater than 0 means positive. Positive is this. This is positive, opens upward. So that's when x is greater than 0. And when double prime is less than 0, that means that double prime is less than 0. That means concavity is going downward, opening downward, and that's on the left side, and that's where x is less than, oh, I said less than, that should be negative 1. This is occurring at negative 1. So on the right side, greater than 0, the concavity is positive, and on the left side, the concavity is negative, so it's y prime is less than 0. So again, this inflection point is occurring at negative 1. So at negative 1, then we have y double prime equal to 0. Greater than negative 1, we have y prime greater than 0 because it's positive. And on the left side, less than negative 1, the y prime is less than 0. Concavity is negative. Okay, let's look at another example. Again, notice this is a cubic. This is positive because it starts here and comes down. Any graph, a polynomial graph that starts on the right and comes down from here. So when it starts here and comes, this is positive. So as the y values become larger, this y value on the graph, as the x value become greater on the right side, the y values are greater, so this is positive. And notice here, as the x values get larger, the y values get smaller, so this is a negative. Okay, so this is a cubic, 1, 2, 3, now cubic. And we have 2, 3 is an inflection point of the f of x. So, if that's an inflection point of the f of x, that means the f of x is equal to 0 when x is equal to 2. So this inflection point is occurring at 2. So, if you have f prime x greater than 0, that means f prime x is positive. Positive is on this side. So greater than 0 is on this side, so that means when x is less than 2. And when f double prime x is less than 0 is a negative, open downward, that's on the right side of the 2. And another way to write this is to go f double prime of 2. So x equals 2, the f double prime of x equals 0. So another way of saying that is the f double prime of 2 is equal to 0. So when x is 2, the double prime is equal to 0. That's when you have this inflection point. Note, each above has a maximum and minimum point. Notice this is a minimum point. And this point right here is a maximum. So because I got a minimum and a maximum on each side of this point here, that means it has, this is a negative concavity, this is a positive concavity. And this is a maximum point here. And this is a minimum point here. So that means this is a maximum, that's a negative concavity, and that's a minimum, this is a positive concavity. So it has to have a maximum and a minimum point in order to have positive and negative concavity. And this another question I thought about doing is these two. Graph g of x if g double prime of negative 2 is 0 and g double prime of x is less than 0 when x is greater than or equal to negative 2, and g double prime is greater than 0 when x is less than negative 2. And this negative 2 is when the g of negative 2 equals 1. So the g, when x is negative 2, right here, x is negative 2, that means the g of x is 1. So that's really this point right here. So this is the point, negative 2, 1, right here. So this is the inflection point, because double prime, g double prime of negative 2 is 0. At negative 2, you get an inflection point, provided you have a maximum and minimum. So let's see. We have, and when x is to the right of negative 2, there's x is negative 2. On the right, we have the second derivative is less than 0. So because it's less than 0 means concavity is downward. So that means it has to go up and then it has to come down. So it has to do this. I'm only indicating that it's going up here and then down. Don't have to be any particular points it's cutting through. And when it's on the left side, when x is less than negative 2, the double derivative is greater than 0, so the concavity is positive. So that means that if it's positive, it goes down and then it goes up again. So I just did the reverse in the question to get you to draw the graph to see the concavity. So again, on the right side, it's a negative concavity. On the left side, it's a positive concavity. Negative concavity, positive concavity. And another question, graph the p of x if pw prime of 3 is 0, pw prime is greater than 0 when x is greater than 3, pw prime is less than 0 when x is less than 3, and it's occurring at the point 3, negative 2. So 3, the p of x, x is 3, the p of x is negative 2. That's the same as the y. So 3, x is 3, negative 2, this is the point right here. So the concavity is positive to the right of the 3. So if we go right, so this is the right of 3, the concavity is positive. That means it goes through here and it opens down and then it goes up. And on the left side of 3 is the negative concavity. So that means it has to open downward. So it goes up first and then it comes down. So notice, again, on the 3, all points to the right of 3, we have a positive concavity. So there's, it's positive, is open, upward. It goes down and then up like a parabola. And then on the left side of 3, negative concavity. So it goes up and then goes down. So that's like a parabola that's opening downward. So this is a minimum point. And this is a maximum point. And again, when it has a minimum point, the concavity is positive. When it has a maximum point, the concavity is negative. And over here, this is a minimum. And this point here is maximum. This is the maximum point on this curve. It's a local. It's not really the maximum. There's no maximum here. This goes on and on forever. But this is what we call a local maximum. And this is a local minimum. And because that's a maximum, it's opening downward. So the second derivative is less than 0. And because that's a minimum, this is opening upward. That means the second derivative is greater than 0. So hopefully that helps you understand about concavity in relation to the second derivative. And if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.